Okay, we've got a as a constant, and we're supposed to show that there are exactly two possible answers for a from this integral expression. First of all, we've got to do the integration, and I've written it out here. And again, this can be turned into two entirely separate integral terms. Now I'm going to write this as x to the power half. So this is 3 multiplied by x to the half, and that's with respect to dx, plus the integral from 1 to 4 of a dx. So with this integral, we've got to raise the power of x to the power 3 over 2 by raising it by 1. And we've got to multiply the 3 by the upside down version of this, which is 2 over 3. I usually check by differentiation. If I want to differentiate this term, 3 over 2 comes straight down. It cancels with the 2 over 3 to leave 3. And yes, the power of 3 over 2 dropping by 1 becomes a half. And this will be done between limits of 1 and 4 and plus. The integral of a dx is simply ax. And again, that's between the limits of 1 and 4. And before we go any further, 3 on the top cancels with the 3 on the bottom there. And now popping in limits and coming down here, we get, so this is 2 multiplied by 4 to the 3 over 2 minus, putting in 1 here, 1 to the 3 over 2 is still 1, so it'd be minus 2. Plus, now the second term, putting in 4, we get 4a, minus, putting in 1 in here, we get a. And this simplifies to, again with this business of raising a number to a fractional power, just split it. This is 4 to the half, itself raised to the power 3. 4 to the half is the square root of 4, which is 2. 2 raised to the power 3 is 8. 2 times 8, 16. So this is 16 minus 2, so this is 14. 4a, take away a, is plus 3a. And that is effectively our answer to the integral that we were asked to do. The integral is equal to that. Now we've got to bring in the fact that the question has told us is that the integral in fact is equal to 2a squared. So now we can put those two facts together. So therefore 2a squared must be equal to our answer here, 14 plus 3a. Hopefully you can see there's a quadratic forming. We need to put everything on the left-hand side, leaving naught on the right, and putting them in order of the index of a. So therefore we get that 2a squared minus 3a minus 14 is equal to naught. Now in these questions, given that it's mainly a question on integration, any quadratic that needs to be solved is probably going to be easily solved by inspection. Let's try it anyway. Set this up. Let's assume one's going to be 2a and a, and let's put the 2 and the 7 there. 2 times 7 being 14. Let's see if this will work out. 2 times 7 is 14, and 2a here in the middle, no, that won't work out. So let's try it the other way round. Let's try this. We've got 7 and 4. Yes, we can make that work. And we can make that work by making that negative and that positive. So let's check it all works. 2a squared, yep. Negative 14, this generates 4a, this generates negative 7a, and the resultant would be negative 3a. So good, we're good to go. So given this conclusion, either a plus 2 is equal to naught or 2a minus 7 is equal to naught. If this first term is equal to naught, the solution would be that a must be equal to negative 2. And if this is true, a must be equal to positive 7 over 2. So that is in fact the answer. We've got our two solutions, and there are indeed exactly two solutions for a. Oh yes, very quickly. Because the question didn't ask us what the solutions were, we could have just looked at the quadratic here and examined the discriminant, which is b squared minus 4ac, and proved it to be greater than 0, in other words, positive. We can just check that. B squared would be 9 minus, now 4 times AC, we've got a negative from the formula, but C is negative. So this will be positive. 4AC, 4 times A is 8, multiplied by 14, which is definitely greater than 0. So this proves that there'd be 2 values of A. And that also would be a perfectly valid solution for the question. There we are.